Hello my lovelies, and welcome to lesson 2 of our little series on light. Hope you got on all right with the last one. So a heads up for this one, it's going to work exactly the same way. I'm going to show you the PowerPoint, and the PowerPoint will be in the file so you can access that if you want to. There are two main activities for you to pause the video and go and do and come back. They're both investigations where you get some choices about what you investigate, and I'll talk you through that when you get there. So there's a little bit more for you to do in this one, which is obviously a good thing because science is all about investigating, isn't it? So I hope you really enjoy this one. So if you have a look at my screen, you will see lesson 2, and this is looking at shiny and matte. Now you might not know the word matte, doesn't just mean short for Matthew. So it's the opposite of shiny. So we might call it dull. So for example, you might have a knife that is shiny and very reflective, or what could be matte, something that is like brushed metal rather than a polished metal, something like that. All right, we'll learn a bit more about that as we go along. Okay, so the first activity, if you want to, if you just understand this straight away, then that's fine. I don't need to see this either way. Is to just make sure that you understand those. So you could look for and list 5 shiny objects, so that are highly reflective. 5 matte objects. Find some things that are around the house that. So here, for example, I've got a sellotape dispenser. I couldn't think of the word there. And I would describe that as matte. It's not shiny, is it? So that's something that's matte. Whereas this is top of a candle thingy. Obviously that's shiny. Might sound basic, but we've got to understand that. And then 5 luminous things. So luminous, remember from the last video, that's all about finding something that gives out light. It's not reflective, it's a light source. And that's explained for you on the right hand side. Okay. So that's your little job, to make sure that you understand shiny, matte, luminous. If you already get it, fine, move on. All right. So here, what we're going to do, this is the first investigation, and this is suggesting that it might take you half an hour. I think that's probably about right. You're going to use, it says here, record your results using a Carroll diagram. Now we have used those in school. I'm just going to flip to the file, the slide that shows you that, and I'm going to put a copy of a blank one of these in the files so that you can have a look at that. You don't have to draw it. So how does it work? Can you remember these? So if you've got reflective here, you'd have to have not reflective there. If you've got smooth here, you'd have to have not smooth there. So it has to be the opposite. We've done these with maths, for example, where we might have had prime number, not prime number, even number, odd number. Remember how those work? And then you put the number in the right box. So in this case, if we looked at reflective and if we choose smooth, you would find something that is reflective and smooth. Then you might write spoon in there. Or if you want something that's reflective and not smooth, that might be harder. You're going to write down what that is in there. Okay. So that's what you're going to do first. Let's go back a slide. So you're going to investigate one of these 3. Are smooth surfaces always more reflective than rough ones or matte ones? Quite an interesting question. Are pale surfaces always more reflective than dark ones? In which case, on your Carroll diagram, you'd have dark, not dark, or white, black, or white, not pale. Or you could look at, are some surfaces reflect equally brightly when the torch is held at different angles to them? So if you've got your torch, pretend this is a torch, and this is your reflective surface, does it make any difference where you hold the torch? All right, you're going to choose one of those. If there's something that you think, oh, I'd really like to investigate this, and it's the same kind of thing that you could use a Carroll diagram for, that's probably fine. Just check with me first that it's going to fit in with this, okay? So what I'll need to see from you at some point is your Carroll diagram. That's all I need to see for for that at that point. So you're going to record your results using a Carroll diagram, and then that's it. So you're going to answer one or other of those questions. So here's that diagram again, the Carroll diagram. And then right at the bottom here, draw ray diagrams to show how they're seen when seen directly and when reflected in a mirror. And I'm going to leave you to think about that, when reflected in a mirror, to give you a little bit of think. Okay, I'm not going to talk you through in too much detail. There's a bit more detail over here. Right, draw a ray diagram showing you how light travels to enable you to see a toy teddy and to see the reflection of a toy teddy in a mirror. So you're going to think, oh, hang on, what must be happening to the light for me to be able to see that teddy in the mirror? You're going to draw me a diagram to show the understanding that you've got there. A little bit tricky. So basically, in that investigation, there's two halves. There's the choose, smooth, white, reflects. Which one are you going to do? Do the Carroll diagram, and then draw me two ray diagrams. One when you're looking at an object directly, and one where you're looking at it in a mirror. I want to see if you can think through what's happening to the light, so that when you're looking at something in a mirror. Okay, that's your first investigation. So if I were you, I would pause the video now, go do that, and then come back when you're ready. All right, but I'm going to carry on and explain the next bit. So next bit is we are going to find out, once you've done that, we're going to find out a little bit more about mirrors. So again, you're going to do another little investigation. You're going to find out a little bit more, and I don't mind how you present this one, doesn't have to be, I'm not specifying. But you're going to find out a bit more about mirrors. Mirrors are really interesting when it comes to light. So you could do anything that investigates mirrors. You could explore reflection from non-flat mirrors. So if you use a spoon, we've got proper convex and concave mirrors in school, but obviously you won't have those at home. But if you use a shiny spoon, you've got a convex. That means this is the convex side, and this is the concave side. I think of it as being like a cave because it goes in. So it's concave, convex. So you could look at yourself in a spoon and think about, what can I see and why can I see that? You might have some toys that have got mirrors. It's giving some examples here. Periscopes are cool. Or this one might be quite interesting. An infinite tunnel using two parallel mirrors. So you get two mirrors and put them like that and try and think about how that works and what happens to the light. All right. You could also, I think some of you will quite like this one, model the reflection of light in a mirror. So it's a funny old thing, but if you have a wall that you could kick a football against, and you imagine that football is drawing a line, which is a bit like a light ray, and you're the light source as you kick that football. And you think about what happens to the football if you kick it at different angles to the wall. So if this is the wall, you might kick it at this angle. Where does the football go? You might kick it at this angle. Where does the football go? And actually, it's exactly the same as what happens with light when you shine it at a mirror. So you might investigate it using that and let me know what you find out. All right. I think that is nearly us done. Yes, there's your glossary, so it might be useful for you if you're doing a little bit of a write-up to use some of that vocabulary. And here at the end, there's some examples of what your Carroll diagram might look like and what your ray diagrams might look like. All right, just if you get stuck, have a look there. Got a little bit of extra information here. All right, so I'm going to put this over here so that you can see. So there was what you had to do in lesson 1. You're going to draw those two ray diagrams. You'll have already done that if you're watching this. This lesson, optional, list 5 of your shiny matte and luminous objects. And send those to me if you want me to check them, that's fine. Optional video about reflection, again, just if it helps you get unstuck. And then you're going to choose one of those questions to investigate. Record your results in the Carroll diagram. That should have a capital. It's named after a man called Mr. Carroll. There's a blank one in the files. And then, and I haven't put this in, you're going to draw 2 ray diagrams. One looking at something directly, one looking at something in the mirror. And you're going to try and use that to explain to me what's happening to light when it hits there. And then that final investigation that's building on those 2 ray diagrams, you're going to find out something. You can do the football one, or you can do the parallel mirrors one, or whatever you want to do. That's going to be interesting, and I should look forward to seeing those. All right, and that is the end of our lesson 2 about light. Hope you really enjoyed the investigations, and I'm looking forward to seeing what you find out.